Hey there guys, my name is Bench and you're welcome to Blinksite. And in today's video, I'm going to show you the basics in using a multimeter. So before we start, if you're not subscribed to this channel, be sure to do that and leave a like and a comment as well in the comment section below. And for those of you that do not know, a multimeter is a measuring instrument that can measure multiple electrical properties such as voltage, resistance, current, capacitance, and many more. And this is what those functions in a multimeter looks like. This here is a continuity function. This function can be used to test various components such as fuses, diodes, resistors, jumpers to verify if there's a cut or a bridge. So guys, a multimeter has 4 female connectors where your probes are going to be connected. So here we have an ohm sign, and the dark one we have a COM, which identifies the negative port. So this is where we're going to be connecting our probes for this test. So now I will adjust the multimeter's knob to the continuity function. By bridging the multimeter's probe, there is a beep sound, which means there's a continuity in the probes. Now, to show how it works, I have a wire that doesn't have a bridge, so I'm going to test that. And now, as you can see, the meter indicates nothing because the wire has not been bridged. And connecting the wires together will create a bridge, and in turn we will hear a beep sound. So now I'm going to test a diode with the continuity function to see if it actually works. And as you can see, there is no reading. So changing the polarity of the probes, we have a reading, which means the diode still works. And so that is it for the continuity function. So let's move on. So now let's look at the resistance function. So we're going to start with the first value here, which is 200, which means 200 ohms. So we can only measure resistors below 200 ohms. But if we go above that, we wouldn't get any reading in the multimeter. So now I'm going to adjust the meters knob to the 200 ohms function. So testing a 1 ohm resistor with this function. So now we have a reading of 1.6 ohms. So moving on to the 2K function. As we all know, 2K is 2000, which means 2000 ohms. As we all know, we can only measure resistors below 2K. If it's above 2K, we don't get any reading. So now I'm going to adjust my knob to the 2K function. So here I have with me a 1 kilo ohm resistor, so let's test that out and see. And as you can see, we have a value of 1.499 ohms, which is just 1 kilo ohm. So that applies for the 20K and the 200K, which I won't be showing how to use. So we're moving on to the 2M function. 2M signifies 2 million ohms. So we cannot measure resistors above 2 million ohms. If we do not get any reading. So tuning the meters knob to the 2M function, I'm going to test a 1 million ohm variable resistor. And as you can see, we have a reading of 1 million ohms. That is a 1.013. And so guys, that is the same thing that applies for the 20M and the 200M. So let us move on to the voltage function. This here is a DC section, which means we can only measure direct current with this function. So let us start up with the first value, which is 200 M, which means 200 millivolts. So tuning the meters knob to the 200 M function, I'm going to measure the electromotive force coming from my body. And as you can see, we have a reading. So this function here can be applied to thermocouples because they generate millivolts. So if we measure anything above 200 millivolts, we might as well damage the meter. And so the same thing applies for the 2-volt function. So now let's move on to the 20-volt function. And so guys, as you might have noticed, my probes are connected the wrong way. So the black probe is going to the COM and the negative is going to the V, which signifies volts. So at this function, we can only measure voltage below 20 volts. So what I want to do is I want to measure this cell. It's a 1.5 volt cell. And as you can see, we have a reading of 1.28 volts. So now let us move on to the 200 volts function. So tuning my knob to the 200 volts function, I'm going to test a pair of lithium ion batteries I have laying around. And as you can see here, we have a reading of 1.5 volts, which means the battery has not been charged. So now tuning the knob to the 1000 volt function, I'm going to test the lithium ion batteries in series. And as you can see here, we have a voltage reading of 2 volts. So now, moving on to the AC voltage function. Beware that we're working with high voltage. If you're not an experienced user, be sure to put on high voltage gloves to avoid getting shocked. So, connecting a power cord to my socket outlet, I can measure the voltage coming from the wall. So, remember that we can only measure voltage below 750 volts, otherwise you're going to get the meter damaged. So tuning the meter's knob to the 750 volts function, I'm going to measure the voltage coming from the wall. And as you can see here, we have a voltage reading of 183 volts of alternating current. So now let's move on to the 200 volt function. So tuning the meter's knob to the 200 volt function, I'm going to measure the wall outlet. And remember, we can only measure voltage below 200 volts AC, otherwise we get the meter damaged. And as you can see, we have a reading of 191 volts of alternating current. See, sometimes alternating current can go higher than 200 volts, so always be sure to turn the meter's knob to the 750 volt function when measuring alternating current. And that also applies for the 20 volts, 2 volt, and 200 millivolts AC. So now, let us move on to the HFE function. So the HFE is just an abbreviation that stands for High Bright Parameter Forward Current Gain Common Emitter. So this function is used for testing transistors. As you can see here, we have an NPN and a PNP function. And here we have some holes as well, so that we can insert the base, connector, collector, and emitter points in the transistors. So here I have a BC547 transistor. So now I'm going to insert it to know if it's a PNP or an NPN transistor. And as you can see here, it indicates with some numbers showing that it's an NPN transistor. So inserting the transistor in a PNP hole shows nothing. This means that this transistor is not a PNP transistor. So now here I have with me a PNP transistor. So as I insert it, it shows some value, which indicates that it's a PNP transistor. So by reversing this transistor, it indicates 0, which means that is not its base, collector, and emitter. So guys, moving on to capacitance function. This function can be used to measure the capacitance of a capacitor. So now, let's start up with the first value here, which is a 20N, which means 20 nanofarads. So tuning the meter's knob to the 20 nanofarad function, I'm going to measure a capacitor with low capacitance. So now I am going to insert the capacitor where we have the capacitor sign in the multimeter. And as you can see, we have a reading of a 0.11 nanofarad. And the same thing goes for the 200 nanofarad. So moving on to the 20U. 20U signifies 20 microfarad. So here I have a capacitor of an unknown value. So with this function we can know the value of this capacitor. Note that this is an electrolytic capacitor, and this capacitor has polarity. So I'm going to insert this in the correct polarity. And as you can see, we have a value of 8.16 microfarad. And so the same thing goes for the 200 microfarad. So let us move on to the AC current measuring section. So here I'm going to start up with the 2M, which signifies 2 milliamp. And so in this section I will change the connection of the probes. Now I will take out the positive probe and insert it in the 20 amp max port. Now I want you guys to know that ammeters are always connected in series with a load. So now I'm going to measure the current output of this AC alternator. And by connecting the probes to the alternator, we are ready to test. And as you can see, we have a maximum current of 104 milliamp. And so guys, the same thing goes for the 20 milliamp and 200 milliamp, and as well as the 20 amp. So let us move on to the DC current measuring section. And so here we're going to start with the 20 mega amp function. So tuning the emitters knob to the 20 mega amp function, I'm going to test the current draw of a DC motor. And so guys, by connecting the motor in series with the battery and as well as the meter, I'm going to test the current draw, which is around 0.04 amp. And so guys, that is it for this video. I hope you enjoyed the video, and if you liked the video, please give me a thumbs up and subscribe to the channel. Thanks for watching.